reflecting sine and cosine graphs. Graphing the basic sine and cosine functions. Recall that the points around the unit circle have coordinates cosine theta, sine theta as shown. Identify the following points on the graph of the sine function on the interval from 0 to 2 pi. The 3 points where x-intercepts occur are going to be, well, here at 0, 0, let's see, 0, 0, pi 0, pi 0, and here, over here at 2 pi 0. The point of the maximum value, okay, well, that would be here, and that's going to be pi over 2 and 1, and down here it's going to be 3 pi over 2 and negative 1. All right, let's see here. B, complete the table of values, plot the points from the table, and draw a smooth curve through them. So 0, well, that would be 0, 0. Pi over 6, that's going to be 1/2. Pi over 2, that's going to be 1. 5 pi over 6 is going to be 1/2. Pi is going to be 0. 7 pi over 6 is going to be negative 1/2. 3 pi over 2 is going to be negative 1. 11 pi over 6 is going to be negative 1/2. And 2 pi is going to be 0. So let's plot these. Let's see, 0, 0. All right, pi over 6 and 1/2. And then pi over 2 and 1. Let me get that right there. 5 pi over 6 and 1/2. Say about right there. Pi and 0, or 0 and pi. And then negative 1, well, let's see. 3 pi over 2 and 7 pi over 6. That was pi and 0, that's right. Here. And then 7 pi, and that's going to be negative 1/2. And then 3 pi over 2 is going to be negative 1. And 11 pi over 6 is going to be negative 1/2. And then here, 2 pi and 0. All right, so it's going to look something like this right here. And there we go. That's the graph. All right. So let's do cosine this time. Identify the following points on the graph of the cosine function on the interval 0 to 2 pi. Okay. The 2 points where the x-intercept occur is going to be let's see here. It's going to be pi over 2 and 0. Pi over 2 and 0. And 3 pi over 2 and 0. All right. The 2 points of maximum value, that's going to be 0, 1, and 2 pi and 1. Okay, the point of minimum value is going to be pi and -1. All right, good. Complete the table of values and plot the points from the table and draw a smooth curve through them. So 0 would be 1, pi over 3 would be 1/2, pi over 2 would be 0, 2 pi over 3 is -1/2, pi would be -1, 4 pi over 3 is -1/2, 3 pi over 2 is going to be 0, 5 pi over 3 is going to be 1/2, and 2 pi is going to be 1. Okay, so we got 0 and 1. Okay. Pi over 3 and 1/2, that's going to be like right there. Pi over 2 is going to be 0. 2 pi over 3 is going 2 pi over 3 is going to be -1/2. It's going to be about right there. Pi is going to be -1. 4 pi over 3 is going to be -1/2. 4 pi over 3. Right there. And then 3 pi over 2 is going to be 0. 5 pi over 3 is going to be 1/2. And 2 pi is going to be 1. Let's draw that. So it's going to start here. And go there. All right. Cool. So the sine or the cosine was the first one, or excuse me, the sine was the first one, and the cosine was this one here. Give a decimal approximation of sine pi over 3. Sine pi over 3, sine pi over 3 is approximately 0.866. All right, what other points can you check based on the labeling of the theta axis? Well, you're going to have 2 pi over 3 and 0.866. You're going to have 4 pi over 3 and -0.866. You're going to have 5 pi over 3 and -0.866. Okay. On the interval 0 is less than or equal to theta is less than or equal to 2 pi, where does the sine function have positive values? Where does it have negative values? And it answers the same thing for cosine. So sine, see positive values will be from 0 is less than theta is less than pi, and negative values is going to be from pi is less than theta is less than 2 pi. All right, cosine positive values. Well, you're going to have from 0 to pi over 2, from 0 is less than theta is less than pi over 2. Okay, that's the first quadrant. See, this right here was the first and second quadrant, and that's third and fourth. Cosine has positive values in the first quadrant and the fourth quadrant. And that's going to be 3 pi over 2. 2 is less than theta is less than 2 pi. And let's see negative values. Negative values is going to be the second and third. Which will be pi over 2. Pi over 2 is less than theta is less than 3 pi over 2. Number 3. What are the minimum and maximum values of f of theta equals sine theta and f of theta equals cosine theta on the interval from 0 is less than or equal to theta is less than or equal to 2 pi? Where do the extreme values occur in relation to the theta intercepts? Okay, let's see. The minimum value of sine theta is -1. And the max value of sine theta equals 1. And these occur halfway between the theta intercepts. All right. Let's see. The minimum value for cosine theta equals -1, and the max value for cosine theta is +1. And again, these occur halfway between the theta intercepts. And I'll show you what I'm talking about. Let's drop back here. Okay, see, halfway between here and here is the minimum, okay? And if I had taken that over one more, you'd see that that's halfway. And if I'd gone over this way, you'd have seen that that's halfway. And let's look at the sine. So you can see here's the intercept, here's the theta intercept, and halfway in between is the max. Here's the intercept, here's the intercept, halfway in between is the min. Okay? All right. Describe a rotation that will map the graph of f of theta equals sine theta onto itself on the interval 0 is less than or equal to theta is less than or equal to 2 pi. So a rotation of 180 degrees clockwise or counterclockwise. About the point. Pi 0. Okay, so that's clockwise or counterclockwise. All right, good. Number 5. Recall that the coterminal angles differ by a multiple of 2 pi and have the same sine value and same cosine value. This means that the graphs of the sine and cosine on the interval 0 is less than or equal to theta is less than or equal to 2 pi represent one cycle of the complete graphs, and that every cycle repeats every 2 radians. Use this fact to extend the graphs of f of theta equals sine theta and f of theta equals cosine theta to the left and right by one cycle. All right, so let's see here. And let's do a different color here. So we have a minimum of 1 here. Okay, and then we're going to have, and then a max of 1 there. Okay, so which means we're also going to have right here. All right, so it's going to look something like this right here. And then here you're going to have max, min, and x-intercept. So it's going to go. Go. All right, and then it's going to look like that. And the same thing here. Now, notice this is the sine here. That's sine theta. And notice how it goes through the origin. Cosine theta, a little bit different. Okay. All right, so that's going to go. And we'll have here, and here, and here, and here, and move that over there. All right, so it's going to go like this. And there we go. Not too shabby. Not too shabby. Graphing the reciprocals of the basic sine and cosine function. The cosecant and secant functions are the reciprocals of the sine and cosine functions respectively. Cosecant theta equals 1 over sine theta, and secant theta equals 1 over cosine theta. All right. So let's see here. This cosecant is going to be undefined. We're going to complete the table of values. Note that whenever sine theta equals 0, cosine theta equals theta is undefined. So this is undefined here. We'll just undefine. And so that's going to be 1/2. So this will be 2. That'll be 1. And that'll be 2. Undefined. And then that's going to be -2, -1, -2, and undefined. And you'll see in a minute why that's undefined. So as theta approaches 0 from the positive side, sine theta approaches 0, and cosecant theta approaches infinity. As theta approaches 0 from the negative side, sine theta approaches 0, but cosecant theta approaches negative infinity. And you'll see what I mean in just a minute. All right. It says, sketch the graph of f of theta equals cosecant theta over the interval 0 to 2 pi. Then extend the graph to the left and right until the entire coordinate plane is filled. Note that the sine function has been plotted for ease of graphing. So I always plot, if I'm going to graph the cosecant, I always plot the sine and then use the sine, and I do it with a like a little, what do you call it? With a light pencil, so I can easily. But and then where it crosses, that's off to the side. Where it crosses, I draw where it crosses the theta axis, and that's off a little bit. I'll grow the asymptotes, and that's still off a little bit. And you'll see why in just a second. This makes it easier to graph. And I'm off on that one a little bit. Nope, I was trying to. And then there we go. You don't have to do the y-axis. That's off just a hair. And there we go. And last one. Draw these asymptotes. All right. So those are the asymptotes. And this makes drawing the cosecant very easy. You ready? It's going to be cool. Epic. I probably should have left that a little bit longer. So the cosecant is going to look like this. It's going to run right close to it, and that's going to go down, and that's going to be its minimum, and then it's going to go right up next to it. And then again, and it gets right up next to them, but it's not supposed to touch. It gets right up next to the asymptotes, but it doesn't really. And then it makes, and this really makes it a lot easier to draw. Smooth lines, smooth lines. I tell you what, I sure do like when the calculator draws them for me. Makes it so much easier. That's probably the closest one to what it really looks like anyway. So there you go. There is f of theta equals cosecant theta over the interval from 0 to 2 pi. Good deal. Complete the table of values. Note that whenever cosine theta equals 0, secant theta is undefined. All right, so 0, 1, well, secant is going to be 1. Let me get my drawing. And let's do this one here in blue. So that's going to be 1. That's going to be 2. Since that's 0, that's undefined. That's going to be -2, -1, -2, undefined, +2, 1. All right. So as theta approaches pi over 2 from the positive side, cosine theta approaches 0. and secant theta approaches positive infinity. From the negative side, it still approaches 0, but this approaches negative infinity. All right. What does this behavior tell you about the graph? The graph has an asymptote at pi over 2. Theta equals pi over 2. All right. So here we go again. Now, again, the easiest way to do it is to first graph the asymptotes. And we got a bunch of them to grow. It really don't take long if you got a ruler. You're doing it on a piece of paper and you got a ruler, it goes pretty quick. It's off a little bit. And there we go. And then there we go. Clean it up a little bit. Those straight pencil marks. All right, since we got it's going to go. And this is secant theta. That wasn't too bad. That looked pretty good. All right. So there is secant theta. How do the domain range maximum values and minimum values compare between the sine and cosine functions and their reciprocals? Well, the domains of the sine and cosine functions are different from the reciprocals. The sine and cosine have unrestricted domains. Okay. In other words, there's no undefined things in it. Cosecant and secant, cosecant and secant functions are restricted when sine theta equals 0 and cosine theta equals 0. All right, respectfully. And then sine and cosine ranges are from -1 to +1. So let's say sine and cosine. Let's see here. Cosine. That's just terrible. Sine and cosine. Ranges are from -1 to 1. Okay. And then secant and cosecant. So, and then cosecant, let's see, cosecant and secant ranges exclude from -1 to 1. That's the only place that they're not at. Sine and cosine, let's see here. Sine and cosine. Sine and cosine. Well, they have a global max of 1. Where'd my pen go? There it is. 1 and a global min of -1. Okay. And let's see, sine and cosine, they have a global max of 1. That's and a global min of -1, where cosecant and secant have local min of 1 and a local max of -1. All right. Describe the vertical asymptotes of the cosecant and secant functions over the interval 0 to 2 pi. Well, the vertical asymptotes occur when theta equals 0, pi, and 2 pi for the cosecant function, and vertical asymptotes occur when theta equals pi over 2 and 3 pi over 2 for the secant function. All right. Good. Graphing f of x equals a times sine 1 over bx, or f of x equals a times cosine 1 over b of x. In Explore 1, you graph the sine and cosine functions on the interval from 0 is less than or equal to theta is less than or equal to 2 pi, which represents all of the angles of rotation within the first counterclockwise revolution that starts at 0. Your drawings are not the complete graphs. However, they are simply one cycle of the graph. The graphs of the sine and cosine consist of repeated cycles that form a wave-like shape. When a function repeats itself over regular intervals on the horizontal axis, as the sine and cosine functions do, the function is called periodic, and the length of the interval is called the function's period. In Explore 1, you saw that the basic sine and cosine functions each have a period of 2 pi. The wave-like shape of the sine and cosine function has a crest where the function's maximum value occurs and a trough where the function's minimum value occurs. Halfway between the crest and the trough is the graph's midline. The distance that the crest rises above the midline, or the distance that the trough falls below the midline, is called the graph's amplitude. In Explore 1, you saw that the basic sine and cosine function each have an amplitude of 1. Note that for trigonometric functions, the angle theta is the independent variable and the output f of theta is the dependent variable. You can graph these functions on the familiar xy coordinate plane by letting x represent the angle and y represent the value of the function. Example 1. For each trigonometric function, identify the vertical stretch or compression and the horizontal stretch or compression. Then graph the function and identify its period. So there's A. Let you go ahead and read through A, and when you get back, we'll do B together. Okay. So we have y equals -3 cosine x over 2. The equation has a general form y equals a cosine 1 over bx. The value of a is -3. Since 1 over b equals 1/2, the value of b is 2. Okay, so let's see. 1 over b equals 1/2. If you multiply both sides by b, you got 1 equals 1/2 b. Multiply both sides by 2, you got 2 equals b. Okay, so that's how that works. So the graph of the parent function must be vertically stretched by a factor of 3. That's the amplitude. And horizontally stretched by a factor of 1/2. Or by a factor of 2. It said 2. I don't know why I wrote 1/2. 2. Graph the function. Note that since a is negative, the graph will be reflected across the x-axis. All right, so here we go. And let's see here. And this is the cosine function, right? All right. So instead of here at 1, since it was stretched by 3, and then it was reflected, so that's going to make that -3, right? All right, then we got pi here, and then we're going to have +3, and then we're going to have 3 pi, and then we're going to have -3 down here, and then, so this is going to be negative, and then pi, +3, and then there we go. All right, so it's going to look something like this right here. And messing that up. And then it goes down here like this. And so there you go. Not too shabby. Find the function's period. So that's going to be 2 pi times the absolute value of b. So that's going to be 2 pi times b is 2. So that's going to be 4 pi. All right. Let's go back and look at that. So it starts here at -2. That's the crest. All right. When does it get? So that's 1 pi, 2 pi, 3 pi, 4 pi. 4 pi, which is what we got. 4 pi. All right, good. Let's see here. For the function y equals a times the sine 1 over b x, or y equals a times the cosine 1 over b x, what is the amplitude? Under what circumstances is the graph of the function reflected about the x-axis, and how is the period determined? Okay, the amplitude is the absolute value of a, which that was 3 in the last example. If a is negative, if a is negative, then it is reflected over the x-axis. All right, good. And the period is determined by the absolute value of b. All right, good. So what do we got here? Your turn. Identify the vertical stretch or compression and the horizontal stretch or compression, then graph the function and identify its period. Okay, so what is A? Let's see here. A is 1/2, right? So we're going to be vertically compressed by a factor of 1/2. What is B? Well, we got 1 over b equals 4, correct? Multiply both sides by b, so you got 1 equals 4b. Divide both sides by 4, so you got 1/4 equals b. So we'll be and horizontally compressed by a factor of 1/4. Okay. So let's find our period. 2 pi times the absolute value of b. That's going to be 2 pi times 1/4. And that's going to give us pi over 2. All right. So we've got the sine function, right? So we know it's going to go through here. Okay. And then we have a period of pi over 2. So let's see here. That's going to be an x-intercept. That's going to be an x-intercept. And here's going to be an x-intercept. And there's going to be an x-intercept. Okay. All right. So we know it's going to go up here. So at, well, let's see here. We're going to have one here, one there, one there, one there. Because that's going to be half of it, right? So it's going to be right there. And then you're going to have 1/2 right here. Then you're going to have 1/2 right there, 1/2 right there, and 1/2 right there. And of course, it's going to come back there. So if this is up there, then that's going to be down here. That's going to be up there. That's going to be down there. And that's going to be up there. And then that's going to be down there. And your graph's going to look something like this right here. Move my hand over a little bit. There we go. All right. Now, let's try this one in the calculator. So let's go to our calculator. And then we've got 1/2, 1, control, divide, 2. And then we have sine, trig, sine, and then it is 4x. 4x. And press enter. Aha. Okay. Now we're sitting here looking at this, and this is on a scale of 1, or 1, 2, 3, and 10. Okay. The graph that we had over here was pi over 2 or pi over 4. So, and it went from -5 pi over 4 to +5 pi over 4. So let's go over here, menu, 4, 1, and for our negative min, we're going to negative x, we're going to put -5 pi, control, divide, 4. And we're going to go to 5 pi over 4. So we got 5 pi, control, divide, 4. And then what was our scale? Our scale was pi over 4, right? So let's do that. Pi divide 4. All right. And min, y min, well, it only went to 1/2, right? So we'll put -1 and +1. And we'll put 1 divide 2, 1/2. All right, let's press enter. And let's see. Now, that looks a little bit more like what we had on our paper. Okay. And you know that 0.785, that's pi over 4. Okay, because that's what we did. All right, good. So we can do this, and we can do it in our graphing calculator. And if you'll notice, they got much smoother curves than I'm able to draw. All right. Explain 2. Writing f of x equals a sine 1 over bx, or f of x equals a cosine 1 over bx. All right. You can write the equation of a trigonometric function if you are given its graph. Now I'm looking at this one right here, and I'm seeing right off the bat, look, it goes through the origin here, so it's a sine. It also has an amplitude of 2. Okay, it has an amplitude of 2, and they're pretty easy to graph. So go ahead and go through A, and then when you get back, we'll do B. Okay, let's take a look at B. Okay, let's take a look at it. I want you to notice something. We're gonna sit there, and then we're gonna draw this right here, and we're gonna draw that right there. It's a little bit low. We're gonna draw that like a little bit high that time, and there. So okay. Now why did I do that right there? Okay, if you notice, it gets up to 1/4 and it goes down to negative 1/4. So my amplitude A equals 1/4. Okay, because it goes through the midline here is the x-axis, so it's 1/4 above and 1/4 below. So again, my amplitude. Now, how in the world am I going to find my B? How am I going to find my B? Well, notice that it doesn't go through the origin, right? So that means it's a cosine function. Because the graph's y-intercept is negative, the graph is a cosine function reflected across the x-axis. So that tells you that A is negative 1/4. Okay? So the maximum and minimum on the graph are 1/4 and negative 1/4 respectively. The graph will be a vertical compression of the graph of the parent cosine function by a factor of 1/4. Now, this is a cosine, right? Okay, so let's see if we can find the period. Let's find the period. The period. All right, you go right here. Okay, that's the trial. When does it reach the trial again? It reaches it over here at 10, right? Okay, and then over here again at negative 10. Okay, 10 and negative 10. So that's going to give us our B. We're going to have, let's see, 2 pi B equals 10, right? Okay, so let's divide both sides by 2 pi, and you get B equals 10 over 2 pi, okay, which is 5 over pi, right? 5 over. So 1 over B, that's going to be 1 over 5 pi, right? 1 over 5 pi. So we're going to put that as pi over 5. Okay, so our equation will be y equals negative 1/4. That's our A. That's our A. Cosine pi over 5x. It's just kind of clumsy, but 1 over 5 pi. And that's simplify. All right. And I kind of did all of that right there already. And so our equation is negative 1/4 cosine, and that's going to be pi over 5x. All right. Here's another chance. Your turn. Write an equation for the graph. Okay. So first off, let's take a look. Does it go through the origin? No, it doesn't. So that means it's going to be a cosine. So we got y equals a cosine. What is that? 1 over bx. Okay, that's going to be our formula. Now we got to figure out our a. What's a? All right. So And let's draw us a little line here. And it goes like that. And it goes like that. That's a little crooked. Yeah, it's still a little up. And there we go. All right. So we got an amplitude. What's the distance from here to here? That's 2. And the distance from there to there is 2. Okay. So A equals 2. That's our amplitude. Now, 2 pi b equals, and then, all right. So let's see here. Here's our top, and let me do it like this. We know the crest is here. That's a little off. It should have been in between. And then we got another crest over here. And okay, so what is the distance between these crests? What's the distance between there? That's 4. What's the distance between here? That's 4. So this will equal 4. 2 pi b equals 4. All right, let's divide both sides by 2 pi. And we got b equals, and that's 2 over pi, right? B equals, 4 divided by 2, that's just going to be 2 over pi. Okay, so 1 over b would equal 1 over 2 over pi, which is pi over 2. So that's going to give us our equation of y equals 2, our amplitude, cosine, and then we're going to have pi over 2 x. And there's our equation. They're not hard, they're just different. They're not hard to graph, not hard to graph at all. Okay. Modeling with the sine or cosine functions. Sine and cosine functions can be used to model real world phenomena such as sound waves. Different sound waves create different sounds create different waves. One way to distinguish sounds is to measure frequency. Frequency is the number of cycles in a given unit of time. So it is the reciprocal of the period of the function. Hertz is the standard measure of frequency and represents 1 cycle per second. For example, the sound wave made by a tuning fork from middle A has a frequency of 440 hertz. This means that the wave repeats 440 times in 1 second. As the tuning fork vibrates, it creates fluctuations in air pressure. The maximum change in air pressure, typically measures in pascals, is the sound wave's amplitude. All right, graph each function and then find its frequency. What do the frequency, amplitude, and period represent in the context of the problem? So let's see here. Go ahead and let's see. Use a sine function to graph a sound wave with a period of 0.004 second and an amplitude of 4 pascals. Graph the function. The frequency equals 1 over the period, which is 1 over 0.004, and that's 250 hertz. The frequency represents the number of cycles of the sound waves every second. The amplitude represents the maximum change in air pressure. The period represents the amount of time it takes for the sound wave to repeat. All right, B, here's where we come in. Use a cosine function to graph a sound wave with a period of 0.01 second and an amplitude of 3 pascals. Note that the recording of the sound wave started when the wave was at its maximum height. That's a hint right there. Okay, the cosine is at it. So, all right. So graph the function. The frequency is 1 over the period, and let's see here, a period of 0.01 And let's see, put that in your calculator and you get 100 hertz. The frequency represents the number of cycles of the sound wave every second. Well, it's not second. S-E-C-O-N-D. The amplitude represents the maximum change in air pressure. The period represents the amount of time it takes for the sound wave to repeat. Okay, so we had, it was 3 pascals, right? That's the amplitude. So we got 3. Okay, it started out at its height. Okay, it has a period of 0.01, so it's going to be back up here at 0.01, right? And again, it's going to be back up there at 0.02. So, and then halfway in between, 0.03, and then halfway between those two will be 0.03. All right, so there we go. And it's going to look something like this. And there you go. Let's just go ahead and bring it back down. It's going to look like that. All right, good. And let's see, your turn. Graph the function and then find its frequency. What do the frequency, amplitude, and period represent in the context of the problem? A pendulum makes one back and forth swing every 1.5 seconds. So you know what a pendulum is. It's like that, and then it's got a rod that goes down and maybe a little ball on it or something like that, and it'll swing this way and it'll swing that way. Okay, a pendulum makes one back and forth swing every 1.5 seconds. So its frequency, how often it does it, will be 1 over 1.5, which is approximately 0.67 hertz. Okay. Its horizontal displacement relative to its position at rest is measured in inches. Starting when the pendulum is 5 inches, its maximum displacement to the right of its position at rest, use a cosine function to graph the pendulum. So it's going to be over here somewhere, and that's going to be 5 inches. All right, and then it's going to swing over there. Of course, that would be negative when it gets over here. That's going to be negative 5 inches. Okay, so we got 5 here. All right, and at 1.5, it's going to be back up here. So 1.5. It's going to be back up here at 5 inches. Now, halfway in between, it's going to be at negative 5. Okay, and that looks like it's kind of over a little bit. There we go. And then somewhere over here is going to be. All right. And then we graph it. It's going to look something like this right here. I have to lift my hand up here. And then it's going to go back up. And it's going to go back down. And boy, that's not one of my better graphs, but you got it. All right, so it's going to look like it. The frequency represents the number of back and forth swings per second. The amplitude represents the pendulum's maximum horizontal displacement. The period represents the amount of time it takes the pendulum to swing back and forth. Okay, so it takes from here to here is 1.5 seconds. Okay, and we'll say from that position there to that position there is 1.5 seconds. All right, good. Number 12, the graph of the sine and cosine are period function. Refer to angles of rotation and the unit circle to explain why this is so. Okay, and let me real quick, let me draw a little. Let's see here. Let's draw this. Let's draw that, and then maybe, and let's see here. All right, the unit circle. Okay, the graph of the sine and cosine are period functions. Okay, this right here, that's one period. Uh, uh, hmm. So since one revolution around the unit circle gives all the possible values of the sine and cosine function, subsequent revolutions repeat those values. Okay, because around here, because remember, it goes, you got, this is 0, -1, or excuse me, 0, 1. That over here is 0, -1. This is 1, 0, and that's -1, 0. Okay. Since one revolution around the unit circle gives all of the values, possible values, we'll put possible values of the sine and cosine functions subsequent revolutions repeat those values. Okay, right there, right here, cosine starts there, it goes to 0, -1, and all those values in between, and then when it gets here, that's why it goes like this. That's why it goes like that. Okay. I didn't mean to draw that. That's why it goes like, shoot. That's why it goes like this. And that would be the y-axis. And that's why it just keeps on repeating. Okay. 13. Referring to angles of rotation in a unit circle, explain why sine negative theta equals negative sine theta and why cosine negative theta equals cosine theta. Use the graphs of sine theta and cosine theta for reference. Okay, and let's see. Since the angles theta and negative theta intersect, make that look a little bit better, negative theta, intersect the unit circle, at points that have the same x-coordinate remember the x-coordinate is the cosine value, but opposite y-coordinates, which are the sine values sine negative theta equals negative sine theta, and cosine negative theta equals cosine theta. All right. How does the unit circle explain why the 2 in sine 2x results in a horizontal compression of the graph of y equals sine x? Okay. As the value of x increases from 0 to 2 pi, as the value of x increases from 0 to 2 pi, one revolution of the circle, the value of 2x increases from 0 to 4 pi, which is 2 revolutions of the unit circle. So the graph of y equals sine 2x completes 2 cycles for every 1 cycle of y equals sine x. Essential question check-in. What is one key difference between the graphs of the sine and cosine function? Well, the sine function always passes through the origin, while the cosine function always passes through the point the cosine function always passes through the point 0a, where the absolute value of a is the amplitude of the function. And that's it, folks. I hope you enjoyed it. I'll see you tomorrow in class. Y'all have a great evening.